Today, we're gonna be talking about Maglev trains. What are they, you may ask? Well, I was traveling the deep dark web when I found this. Maglev is actually derived from the words magnetic levitation. It is a train system that uses magnets to repel the train off of the track and to push the elevated train forwards. This system takes advantage of how two like magnetic poles will repel against each other, which is the exact situation happening between the guideway and the bottom of the train. This repel between the two magnets is a long-range magnetic force, which outweighs the gravitational force on the elevated train, allowing it to stay up. The lack of use between the wheels and the track make for friction to be less present when the train moves, therefore allowing this object to move even faster, reaching speeds of more than 200 miles per hour. With no track, normal force is not present in the picture as well, as there is no push against a surface and thus no force exerted by the surface. Now, with all of this in mind, you may be asking, well, how does the train begin to move in the first place? That's when my boy Isaac Newton comes in. Newton's first law states that an object at rest tends to stay at rest, while an object in motion tends to stay in motion unless acted upon by an unbalanced net force. As you can see from this train, there's an unbalanced net force between the force from the magnets and the little to no friction acting against the train. Since the magnetic force is much greater, this allows the train to move from rest to acceleration. What I mean when I say that the train moves from rest to acceleration is that the train's velocity changes over an interval of time. Since we see that the train's speed increases, therefore we can also say that there is an acceleration. Now that we've discovered Newton's first law, let's discover Newton's second law too. This law states that F net is equal to ma, and it is usually used to find the total force along the x or y plane. Now, you're probably wondering, Phoebe, what does F net equal ma even stand for? Well, m is the mass, a is the acceleration, and F net is the total sum of the forces in either the horizontal or the vertical direction. The reason the maglev train is able to move so speedy is because of the F net force along the x-axis. Since there is no friction involved, the F net force is much greater, therefore allowing the train to move at a much higher acceleration. In conclusion, there are a lot of cool stuff happening with maglev trains. Currently, these type of trains are only available in China and South Korea, even though Japan is still constructing one, which is set to be finished by 2027. But hopefully it comes to Canada before we die.